Verniers. Standard micrometers have two scales, one on the barrel and one on the thimble. Each graduation on the barrel scale registers a travel of the spindle of 55 1/1000ths, and each graduation on the thimble scale registers a travel of the spindle of 1 1,000th. It is possible to read a fraction of a thousandth on this micrometer, for instance, 1/2 of 1 1,000th. But in order to make the standard micrometer read in 1/10 of 1,000th, each division on the thimble scale would have to be divided into 10 parts. If this were done by engraving graduations directly on the thimble scale, the divisions would become so crowded that they would be difficult to read. There is a third scale on the barrel of some micrometers which is called a Vernier scale. This provides an easy means for dividing each thimble graduation into a number of parts. The Vernier scale makes it possible to measure 1/10,000th part of an inch. Before studying the Vernier scale on the micrometer, let us study the general principle of all verniers in a somewhat simpler form. Instead of 10 divisions, this Vernier scale has but 5 divisions. These 5 divisions span the same distance as 4 divisions on the main scale. A Vernier scale having 5 divisions would be called a 5-part vernier. The Vernier principle, which is illustrated here in its simplest form, depends upon the use of 2 scales, one of which is the main scale, which may be graduated in any desired units of length or parts thereof. The other scale is the Vernier scale, and its function is to subdivide each main scale division. With a 5-part vernier, each division of the main scale can be subdivided into 5 parts. Since there is one more division on the Vernier scale than there are divisions on the main scale, it is evident that each vernier division is proportionally smaller than a corresponding division on the main scale. Because this is a 5-part vernier, each vernier division is 4/5 of each main scale division. Therefore, each vernier division is 1/5 smaller than any single division on the main scale. When the number 1 graduation on the vernier is lined up with any graduation on the main scale, then the distance between the 0 index on the vernier and the graduation nearest to it on the main scale will be 1/5 of a main scale division. The number 1 index on this Vernier scale always shows a reading of 1/5 plus the reading on the main scale when it lines up with any main scale graduation. In this case, the reading is 3 1/5, 3 from the main scale plus 1/5 from the Vernier scale. We can lay down a general rule for all verniers used on linear measuring tools. The Vernier scale can divide each main scale division into fractional parts. The denominator of the fraction is the number of divisions on the Vernier scale, and the numerator of the fraction is the number of the Vernier index which lines up with any main scale graduation. Moving the main scale to line up the number 2 index of the Vernier scale to the main scale graduation nearest to it adds 2/5. The reading becomes 3 2/5. The number 3 index on a main scale graduation, and the reading becomes 3 3/5. The number 4 index, and the reading becomes 3 4/5. Number 5, that means 5/5 or a whole. The reading is 3 plus 5/5, which is 4. Note that now the 0 index lines up with a main scale graduation. When the Vernier scale is at this setting, only the main scale graduation should be read, the graduation over the 0 index. Remember that each main scale division can be divided into fractional parts, the denominator of which fraction is the number of divisions on the Vernier scale. The numerator of that fraction is the number of the Vernier index which lines up with the main scale graduation. Now let us study a 10-part vernier. Note that this vernier scale has 10 divisions spanning the same distance as 9 divisions on the main scale. A 10-part vernier scale is used on the vernier micrometer. The vernier scale engraved on the barrel spans the same distance as 9 divisions on the main or thimble scale, as we can plainly see if we unwrap the two scales to produce a straight line diagram. Before we study the diagram of the two scales, let us review the reading of the barrel and thimble scales in hundredths and thousands. The number 3 shows on the barrel scale. That's 300 thousandths. 2 divisions on the thimble scale beyond the 10 index register 12 thousandths. The reading so far is 312 thousandths. The number 12 index on the thimble scale has moved past the barrel index for part of a division, indicating a measurement larger than 312 thousandths. How much larger can be determined by the vernier scale. We see that vernier index number 5 lines up with a thimble scale graduation. The number on this thimble graduation is disregarded in reading tenths of a thousandth. Only the vernier scale number is read to obtain the final measurement in parts of a thousandth. The value of this number is added. The full reading becomes 0.3125. 312 thousandths plus 5/10ths of a thousandth. This total is the distance between anvil and spindle. Now let us return to the diagram of the vernier scale. Since each scale division on the micrometer thimble represents 1/1000th of an inch, then setting the number 1 mark on the vernier opposite the nearest index on the thimble scale shows a difference at the 0 vernier index of 1/10th of 1/1000th, or 1/10,000th of an inch. We will repeat. First, we find the vernier and scale set at 0. To read 1/10,000th, the thimble is moved so that the graduation on the thimble scale, which is nearest the number 1 graduation on the vernier scale, will coincide with that graduation. The reading in tenths of 1/1000th of an inch is always done by finding the vernier index, which lines up with any graduation on the thimble scale. Read only the vernier number to determine the reading in 10,000ths. If a thimble scale graduation lines up with vernier graduation number 2, that means a reading of 2/10ths of 1/1000th of an inch. Moving the next scale graduation to the number 3 line on the vernier gives 3/10,000ths, the next 4/10,000ths, the next 5/10,000ths, the next 6/10,000ths, and so on, 7, 8, 9, 10,000ths. Another, and both zeros on the vernier, line up with scale graduations. None of the other vernier index marks line up with any of the scale graduations. You have received a detailed drawing of a stud, which is to have a diameter of 0.3125, with allowable tolerances of plus 3/10,000ths and minus 0. You are to make this stud from a drill rod and have obtained the stock. You make sure that the stock is of the specified diameter within the tolerance allowed. Your micrometer reading shows 3 on the barrel scale. As you know, that's 3/10ths of an inch, 300 thousandths. The thimble scale shows 2 graduations beyond the 10 index, that's 12. The thimble scale reading represents 12 thousandths. That's as far as you can carry the reading on the barrel and thimble scales. To carry the reading to tenths of 1/1000th of an inch, turn the micrometer so that you can read the vernier scale. You find that the number 5 index on the vernier is the only vernier index which lines up with the graduation on the thimble scale. You know that this number 5 index represents 0.0005, 5/10,000ths. You add 5/10,000ths to the other scale readings and obtain a total of 0.3125. This is exactly the size called for on the drawing. Precision measurement, particularly when using the vernier micrometer, requires an exact feel that can be acquired only by experience. It is important that every user of a micrometer practice until he is able to obtain uniform readings. Only by practice can he learn how much tension to use in bringing the spindle into contact with the work. Among other measuring instruments which employ the vernier principle to increase their range of precision are vernier calipers. The vernier scale on the vernier caliper operates on the same principle as the vernier scale on the micrometer. However, it differs in the number of divisions. Whereas the vernier on the micrometer is divided into 10 parts, the vernier on the caliper has 25 parts and is called a 25-part vernier. The 25 parts on the vernier caliper cover 24 divisions on the main scale. There is a vernier scale on each side of the caliper. One is marked outside and is used in taking outside measurements. The other is marked inside and is used in taking inside measurements. The numbers on the inside scale read from right to left, and the numbers on the outside scale read from left to right. The main scale is graduated in inches, each inch graduation being numbered. The other numbers on the scale are in tenths of an inch. Each of these numbered divisions equals 1/10 of an inch, 100 thousandths. Each tenth of an inch space is divided into 4 parts. These graduations are not numbered. Each of these small divisions on the scale equals 0.025, 25 1/1000ths of an inch. The vernier scale spans 24 divisions on the main scale, and the vernier scale has 25 divisions. This vernier scale is usually numbered at every 5th index, 0, 5, 10, 15, 20, 25. Since the vernier scale has 25 parts within the same length as 24 divisions on the main scale, the vernier scale divides each division of the main scale into 25 equal parts. Each main scale division equals 0.025 inches, and each vernier division is 24/25ths of this. Hence, the difference between a vernier division and a main scale division is 1/25th, and 1/25th of 0.025 equals 1/1000th. This is the smallest dimension the instrument can measure accurately. The vernier scale in the position shown has the 0 index lined up with the graduation on the main scale. The 25 index is also lined up with the graduation on the main scale. All the other vernier lines are in positions at various distances from the main scale lines. When the scales are in this relationship to each other, the vernier caliper is set to some reading ending in multiples of 0.025. In this case, the reading is 6 125 thousandths. 6 from the inch graduation, plus 1 from the tenths graduation, 100 thousandths, plus 1 of the 0.025 inch divisions, 25 thousandths. The vernier reading is 6.125. Moving the scale so that the number 3 vernier index lines up with the nearest main scale graduation adds 3 1/1000ths to the reading, 0.003. The total becomes 6.128, 6 inches and 128 thousandths. Here is a vernier caliper being used to measure the diameter of a cylinder being turned in a lathe. The fixed jaw is held firmly against the work, and the movable jaw is brought into approximate contact with the work. The final adjustment is made by the adjusting screw on the clamp, which brings the movable jaw into intimate contact with the work. When the feel of the jaw as it is moved on the work is just right, the locking screw on the movable jaw is tightened. After tightening the screw, check the feel. The reading is taken from the scale marked outside. A magnifying glass facilitates reading the scales. As you can see, the reading is a little over 6 inches. The vernier shows that one line beyond the number 10 index coincides with one of the graduations on the main scale. The reading of the vernier indicates 11 thousandths. Hence, the complete reading is 6.011. 6 inches and 11 thousandths. Vernier calipers are made in several sizes from 6 inches to 48 inches. Here's a 24-inch caliper measuring work being produced on a vertical boring mill. The vernier caliper is also used for taking inside measurements. The fixed jaw is held firmly against the work and the movable jaw brought close to the other side. The clamp screw is tightened and the adjusting screw is used to bring the jaw into contact. When the drag of the jaws on the work feels just right, the locking screw is tightened. The setting is checked for the right feel to make sure that the caliper has not been disturbed by tightening the locking screw. The reading is taken from the scale marked inside. The reading is 4 inches on the main scale. The vernier index is near the number 4 index on the main scale, 400 thousandths, and 3 spaces beyond. 3 times 0.025, that's 0.075, 75 thousandths more, and 20, 21, 22, 23, 24 on the vernier. The addition gives 4.499, 4 inches and 499 thousandths. A drawing of the part that has just been measured shows an internal diameter of 4 and 500 thousandths with a plus or minus tolerance of 2 thousandths. The reading of 4.499 is well within the limits specified by the drawing, and the work will pass final inspection. We have seen 2 types of measuring instruments which employ the vernier principle. The vernier scale on the micrometer makes it possible to divide each thimble scale division into 10 parts, thus extending the ability to take measurements with the micrometer to within 1/10 of a thousandth of an inch. Naturally, great care must be employed in using the vernier micrometer in order to attain the precision of measurement of which it is capable. As with all good tools, the vernier micrometer must be kept clean and free from attack by rust and corrosion. It is equally important that the vernier caliper be handled with care, particularly since there is no way of making any simple adjustment for wear and misuse. The only way to treat fine tools is to give them the careful handling and good care they deserve.